We're going to look at some problems that I don't remember when exactly these started appearing on the AP exam, but what they would have is instead of just a single thing that was changing, you would have multiple things that were changing in a problem. And frequently it would be one rate where something is growing and another rate where something is decreasing at the same time. So, in a population, you might have one where you have a birth rate and a death rate, that sort of thing. So let's take a look. So on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t is equal to 90 plus 45 cosine of t squared over 18, where t is measured in hours and t is between 0 and 8. Just notice that, as I pointed out to you the other day, they're going to give you a rate, but they're not going to tell you that it's a derivative of something. Okay. All right. At the beginning of the workday, at t is equal to 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, from 0 to 8, the plant processes gravel at a constant rate of 1,000 tons per hour. Excuse me, 100 tons per hour. All right, so first thing, they ask you, what is G prime at 5? Now, could you do this by hand? Absolutely. Do you need to? Absolutely not. Okay, do not waste time doing things that you don't need to do. Man, that's a weird looking car. Yeah, I'm like, it looks like something out of a bad sci-fi movie from like the 80s. So, all we need to do is use your calculator to find that. And if you suspect at all that you're going to have to use that equation in your calculator more than once, it's worth it just to go ahead and put it into Y1, and then you can do whatever you want to with it whenever you want without having to retype it every time. That way you only have to type it once. And I suspect that we're going to have to on this, so I'm going to go ahead and just clear anything else that's in there out. So 90 plus 45 cosine of x squared over 18. So I'm going to quit out of that. I'm going to say find the derivative, which is math 8. The derivative with respect to x of, to get to that, it's alpha trace. And it's just right there, y1. And I want to evaluate it at 5. Bada boom, bada bing. So that's negative 24 point whatever it was. Negative 24.5 something. What is it? 587. All right, so that's the derivative. Now we need to, using correct units, interpret your answer in the context of the problem. All right. So G of t is the rate at which gravel's being processed. So G prime of t would be what then? It's a little weird.
The rate at which that rate is changing?
Yes. Okay. G prime of 5. I shouldn't be trying to write it down here. I'm never going to fit it in. G prime of 5 is the rate at which the rate of gravel is processed is changing. at time t is equal to 5, and t is measured in hours, right?
Yes.
Measured in, well, we know g of t um, is in tons per hour, right? So it would be tons per hour per hour. And part of what's nice about this is you don't have to write the negative 24.587 here, because you at some point have said g prime of negative 5 is g prime of 5 is this number. So what's happening to the rate at which gravel is being processed?
It's decreasing.
It's decreasing. So if you want to talk about that, you can. I don't know that it's a requirement. I feel like I ought to. I would probably say, since this is negative, we know that the rate at which gravel is being processed at the plant at time t is equal to 5 is decreasing. All right, let's go ahead and go on to part B, though. I'm going to erase all this stuff. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. Well, that is what we're doing right now, right? That's just going to be the integral from 0 to 8 of g of t dt. And again, since we've put that into your calculator already, we can just do math 9, the integral from 0 to 8 of y1 with respect to the variable x. So that's 825.551 tons. All right, here's where you start to get some interesting questions. Is the amount of unprocessed gravel at the plant increasing or decreasing at t is equal to 5 hours? Show the work that leads to your answer. All right, so to find where an amount is increasing or decreasing, we would need to look at the derivative, right? So, and they've given us the rate in g of t, and they've given us the rate out. It's processed at 100 tons per hour. So if a of t is the amount of unprocessed gravel at the plant, a prime of 5 is going to be equal to g of 5 minus 100. Right, because g is the rate at which it's coming in, and 100 is the rate at which we're changing it from unprocessed gravel to processed gravel. So again, we can do that on the calculator. We can simply evaluate y at 5. So again, alpha y of 5 minus 100 is negative 1.859, which is less than 0. So the amount of gravel, unprocessed gravel, is decreasing. All right, then the last part. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? All right. So the amount that we have is going to be equal to, well, how much did we start with? 500 tons, right? Always think about what you started with. Plus, we're going to process the gravel from 0 to t at a rate of g of t. Right, so this is how much we have processed minus the amount that's coming in minus the amount that's been processed. Now, we're processing it at a rate of 100 tons per hour. So to find the amount that's been processed, that's going to be 100t. Let's stop there because this is a point where a lot of people just absolutely, lost it. They couldn't quite figure out how to get this equation. But does that make sense? So how much we had, plus, since this is the rate of change of how much is coming in, we take the integral of that to find out how much actually has come in. And we actually, for this part, you could have done the integral from 0 to t of 100 dt, couldn't you? So when we take in order to find the maximum, we need to take the derivative. A prime of t is g of t minus 100. That's part of why they asked you part C. They were trying to kind of tip their hand that this is where you were going. And we want that to be equal to 0. Okay, so let's grab the calculator again. And I'm going to try something. Haven't tried this before. There is a solver on your calculator. For the most part, it sucks. And now I got to find it. I can't see this very well. I use it so infrequently I can never remember where it is.
Is it by enter?
Oh, yeah. So let's try it. Alpha enter. No, that's not it. Hang on just a second. Well, let's see. Let's try something. Y1 minus 100. There is an equal sign on here someplace. Again, I just never use it. Hang on a moment. Well, at this point, it's taking longer than it's hidden someplace. Tell you what, I'm going to do it a different way. I'm going to go up to y equals. I'm going to turn this one off because I really don't want to see it. And I'm going to say y1 minus 100. I'm going to set my window from 0 to 8. Oh, and there it is. So I need to find where that is. Find the 0. And it's 4.924. And then the amount at 4.924. And I'm going to go ahead and put dot, dot, dot because since that's not a final answer, I really don't want to round it off. So now I can use this equation. So quit out of that. I'm going to do 500 plus math 9, the integral from 0 to, the nice thing is that it still has that value that I just calculated in its head, and it won't forget it until it does something else. So I'm just going to put x up here. It still has that value. You don't have to store it. This is y1 with respect to the variable x minus 100x. $635.376 tons. It also says justify your answer. So A has a local max at t is equal to 4.924. How do I know that that was a local maximum from the graph?
Switch from positive to negative.
Exactly. Because A changes from positive, A prime changes from positive to negative. And since this is the only critical point, of A on the interval from 0 to 8 it must be the absolute maximum. The other way to justify that it's an absolute maximum would be to say this is more than 500, which is where it started, and then find out the amount that was there at the end. This is faster. A little bit more writing, but you don't have to find out how much there was at the end of the day. I think the next page is the rubric, right? Let's see if I got any of those numbers right. On part C, I actually found the difference. They just said, since that's less than 100, all right, let's go on to the next one, see how far we can get into this at least. All right, so the rate at which people enter an amusement park on a given day is modeled by the function E, defined by bleh. The rate at which people leave the same amusement park on the same day is modeled by the function L, which is defined by equally bleh. Both E of t and L of t are measured in people per hour, and time t is hours after midnight. These functions are valid for 9's less than or equal to t's less than or equal to 23. So it's open from 9 in the morning until 11 at night. At time t is equal to 9, there are no people in the park. And by people, I'm assuming that they're talking about customers, not there's no people in the park. Obviously, there's people that are working there. How many people have entered the park by 5 o'clock p.m.? That is, t is equal to 17. Well, that's just going to be the integral from 0 to 17 of e of t dt. And in the interest of time, somebody peek onto the rubric and tell us what that is. 6,004. Notice here it says round your answer to the nearest whole number. It gives you that clue that we're not going to count, quarters of people and the like. So it says the price of admission to the park is $15 until 5 o'clock. After 5 o'clock, the price of admission to the park is $11. How many dollars are collected from admissions to the park on the given day? Round your answer to the nearest whole number. All right, well, we already know that 6,004 people come in before 5 o'clock. So that's going to be 15 times 6,004. Plus, we're going to charge $11 for the people who come in after that. So it'll be 11 times the integral from 17 to 23 of e of t dt. You may want to round the integral off before you multiply it by 11. But what does it give us for this?
$104,048.
All right, and here's where it gets interesting. Let h of t be the integral from 9 to t of e of x minus L of x dx for the time interval from 9 to 23. Find the value of h of 17 to the nearest it says the value of h of 17 to the nearest whole number is 3,725. Find the value of h prime of 17, and then explain the meaning of h of 17 and h prime of 17 in the context of the amusement park. So there's several things they're asking us to do here. And I know some of you guys are bad about doing the first thing, but not, all the things. You got to be really careful about that, especially on the AP exam. They'll ask you multiple things a lot. So first, find the value of h prime of 17. Well, h prime of t is going to be just e of t minus L of t, right? So for h prime of 17, again, we just would use the calculator to find e of 17 minus L of 17. And again, because we're a little short, what does that come out to be?
Negative 380.2.
0.281. Thank you. All right, so then it says explain the meaning of h of 17. All right, h of 17. All right, so we've got people entering the park and people leaving the park. What is this going to tell us? Well, this would be the number of people that have entered minus the number of people who have left, which gives you the people who are in the park is the number of people in the park. At 5 o'clock p.m. And we won't take the time to write it out, but what's h prime of 17 going to tell you?
The rate that people are leaving.
It would be the rate at which the number of people in the park is changing.
That's
Right? Because h of t is the number of people in the park. H prime is going to be the rate at which the number of people in the park is changing. So that means that more people are leaving than are coming in. All right. You guys have a great day.